In this video, we are going to learn about the bus, which is used to interact between the different components of a computer. Bus interconnection. This is how actually the bus in olden days of computers look like. It is a pathway connecting two or more devices. We can connect more than one device with the help of a bus. A bus consists of multiple communication pathways, or we can say them as lines. Now, if you see here, there are so many lines showing, and it is used to transmit one bit of binary data. So, that is either 1 or 0 we can transmit using each line. Transmitting a word across a single line bit by bit, we say it as a serially. So, one single line if we are using to transmit a data, to transmit a complete 8-bit word or 16-bit word, we say bit by bit we are supposed to transmit, because only single line means only one bit of information we can transmit. So we call this as serial transmission. Several lines of a bus can be used to transmit binary digits simultaneously. That is parallel transmission, we say. So if we are using the number of lines equal to the number of bits in a word for transmission, then we call it as parallel transmission. For example, an 8-bit unit of data can be transmitted over 8 bus lines. And the bus that connects major computer components, we say as a processor, memory and I/O, we call it as a system bus. The lines can be classified into 3 functional groups, that is data, address and control lines. So we call it as a data bus, address bus and control bus. So data bus or data lines. It provides a path for moving data among system modules. So if we want to take the data from the memory or write something into the memory, data bus is required. Similarly with I/O modules also. The data bus may consist of 32 lines, 64 lines or 128 lines or even more actually, and this particular size we say as width of the data bus, or we can say simply say as data bus size. If the data bus is 32 bits wide and each instruction is 64 bits wide, then we are supposed to take 2 times in order to fetch the complete instruction. So what we said, the memory module is accessed twice for fetching one single instruction. Address lines or address bus. This is used to designate the source or destination of the data on the data bus. When we are talking about read or write operation of the bus or with I/O module by the processor, so we are supposed to provide from where we are supposed to read or where we are supposed to write. So that particular address will be communicated to the memory or I/O module by the processor using address bus. So for example, if the processor wishes to read a word, either 8-bit, 16-bit or 32-bit of data from the memory, the corresponding address need to be put onto the address lines. Then control bus. This is also called as control lines, which is actually used to generate the control signals to show what operation need to be performed by the processor. That is, whether read operation to be performed or write operation to be performed. Control signals transmit both command and timing information among system modules. Timing signals indicate the validity of data and address information. That is, some data if we have put onto the data bus and address onto the address bus, during which particular time it is valid, that will be indicated by the timing signals. Command signals specify the operation to be performed. Some examples of the control lines are memory write, which is used to indicate that write operation is to be performed in the memory. Memory read causes data from the addressed location to be placed onto the bus. That is, content from the memory will be placed onto the data bus. IO write means the data on the data bus is written to the IO devices. IO read, from IO devices via IO port we are reading onto the data bus. Transfer acknowledgement, that is indicating that the data have been accepted, that corresponding acknowledgement will be sent. Bus request indicates that the module needs to gain the control of the bus, that is any module which requires to access the grant of the bus, then bus request signal need to be generated. Actually this will be used in the case of DMA process. Similarly bus grant, then interrupt request. In interrupt cases, interrupt request will be used. Interrupt acknowledgement, clock is used to synchronize the operations. General control signal which will be most of the times generated. Reset initializes all modules. Very few times the reset will be used. The operation of the bus. If one module wishes to send data to another, it must do two things. So let us say that processor wants to send data to the memory, obtain the use of the bus. Generally the processor will have the control of the bus and transfer data via the bus. So processor will be putting the data onto the data bus and address onto the address bus and can perform the write operation using the bus. If one module wishes to request data from another module, it must obtain the use of the bus and transfer a request to the other module over the appropriate control and address lines. So it has to transfer a request that it is ready to receive the data, and so appropriate control signals and address lines need to be generated. Then after generating the control signals, it has to wait for the other side module to send the data so that this module can receive it.